Hello, good morning students. Welcome to TOES classes, and today I am going to explain you electric field. Today we are going to discuss an important topic in class 12 physics cbse board, and the topic is electric field. Okay, let us see what is electric field. Suppose I have a source charge. This is a source charge plus q. Okay, if I take a test charge plus q naught, what I take? A test charge plus q naught. What is test charge? Actually, a test charge is the charge of very small magnitude. So test charge is a point charge of very small magnitude. It means its magnitude is very small, and in some book it has been written as a q naught. It approaches to 0 but not equal to 0. Okay, so I have a source charge, and when I try to take this test charge near to the source charge, that I have considered a source charge. A source charge is the charge which is has high magnitude. This is a source charge. When I take this point charge plus q0, that is a test charge, close to source charge, I experience a force or an electric force. Okay, and when I take this test charge away from the source charge, the force is less or almost negligible force act. So the region around the source charge, this region around the source charge in which a test charge experiences a force is known as electric field. So space around the source charge in which a test charge experiences electric force is known as electric field. Clear? This electric field may be defined as like this one, how it can be defined. But before that, suppose this test charge is very close to the source charge, a force act on it. That force is known as electric force. Okay, so the electric force I am going to write down, it can be written as F is equal to, that is the magnitude of the electric force. What I write here, that is the magnitude of electric force, and E is the electric field. So I can write down, this is the Q naught, E intensity of electric field as F upon, I can write it, but I know that electric field is vector quantity, and these two charges are positive charges, and we know that like charges repel each other, so force will act in this direction, that is the F, and that will also be the direction of electric field, like this one. The electric field is the direction of the force which has been experienced by a test charge which is placed in an electric field. So you can write down E is equal to F upon Q naught. You can also write down in some book more accurately. If I have to write down the electric field, the intensity of electric field at any point around a source charge is given by the expression, this is the expression F upon Q naught. So it means the value of Q naught approaches towards 0 but not equal to 0. So we can define, this is known as the intensity of electric field. What is this one? This is intensity of electric field. So intensity of electric field inside the electric field is defined as the ratio of the electric force experienced by a test charge to the magnitude of the test charge. Now I can write down the SI unit of electric field. Yeah, SI unit of electric field, you can write it as the unit of force is Newton and unit of charge is Coulomb. So you can write Newton Coulomb to the power minus 1. That is the SI unit of electric field. Electric field is a vector quantity because it has both magnitude as well as direction. Next thing that I have learned, electric field is a vector quantity as it has both magnitude and direction. So what we have learned? We have learned what is electric field, what is the intensity of electric field, what is the definition of electric field, what is the SI unit of electric field, where electric field is which type of physical quantity. Once again going to revise it. Electric field, the space around a source charge in which a test charge is the charge of very small magnitude. It approaches towards 0 but not equal to 0. The space around a source charge in which a test charge experiences an electric force is known as electric field, the region. Okay, and the electric force on the test charge is given by the expression F is equal to Q naught E, where the magnitude of force is 1. So you can write E is equal to F upon Q naught, and more accurately, the vector E, the electric field, is equal to limit Q naught approaches towards 0, F upon Q naught is the intensity of electric field. And the SI unit of electric field or SI intensity of electric field is Newton per Coulomb. It is a vector quantity as it has both magnitude as well as direction. Now we are going to calculate a very important topic, and that is the electric field due to a source charge at a point at a distance r from a very important topic. This topic generally asked in 2 marks, that is derivation. I am going to derive it here, and you can write theory back your own. Let's see how we can derive the expression, the intensity of electric field. What I am going to calculate, the intensity of electric field. Suppose this is a source charge plus Q. This is a point P. This is a point P. Point P is at a distance R. Point P is at a distance R from source charge. This is our source charge. What is this? This is source, and I have to calculate the intensity of electric field at point P. So what I have considered here, I assume that a test charge plus Q naught is placed at point P. What I have considered, that a test charge plus Q naught is placed at point P. We know that plus Q, that is plus Q, that is large in magnitude, small in magnitude. That's why there will be force of repulsion. So you can write down, it will be repelled like this one, force. So I can write down the force of repulsion between these 2 point charges which are separated by a distance r between them, and they are placed in vacuum. Where they have been placed? Vacuum. I consider this is equation number first. Okay, now I have to write down therefore the intensity of electric field, but you have to mention the direction here. The direction you can write down, if you have to write down in vector form, you can write r cap. I write this is r cap, that is the unit vector which is pointing away. Okay, now I can write down E, intensity of electric field. Recently I have learned F upon Q naught. Going to place the value, let's see what result I am going to get. 1 upon 4 pi epsilon naught Q naught divided by Q naught and into square. Q naught get cancelled from Q naught. You get that is away from point P. This is away from point P. So now I can write down the intensity of electric field 1 upon 4 pi epsilon naught capital Q upon R square. and the direction r cap. Okay, if I have to write down the magnitude of an intensity of electric field 1 upon 4 pi epsilon naught q upon r square, that is the expression for electric field due to a source charge which is at a distance small r from it. One important and conceptual question is generally asked. Kindly, the question may be asked like this one: show the variation of electric field due to a source charge with the distance. Very important, generally asked in 1 or 2 marks. If we plot a graph between intensity of electric field and R, it comes out to be like this one. So what you have observed that the intensity of electric field varies very fastly as the distance increases. I hope that you understand this video very well. If there is any confusion, then you can send your comment in comment box. I will try to sort out your problem as soon as it is possible in my next period. Thank you and have a nice day. Thank you very much.